What if I told you some scientists are creating metabolic diseases in the lab just to sell you the solution? The latest D-Lactate study might be the most shocking example yet, and the truth will make you rethink modern health research. Hey everyone, my name is Marc Bates. I'm a metabolic health coach, and this is part of my Roasting Sacred Cows of Nutrition series. Did science just manufacture this disease? The truth behind the D-lactate trap. Okay, um, so let's get into this one. This is a research review, but it's also a roasting. I didn't know which one to put it in, so here it is. So there was this ad I saw, or it was a post, and it obviously was an ad. And they said new scientific research proves that D-lactate causes inflammation, type 2 diabetes and stuff. They weren't quite that dramatic, but they said, this is it, and we have a solution for it. It's a polymer that locks it in, right? And you can buy it now because it's a supplement. Okay, it's an expensive supplement, but you can buy it. It's a supplement. And this is the study. So the first thing is notice it's listed as an article, which more than likely means that it was a paid article as opposed to a research study that went through a peer review and all that for the Cell Metabolism journal. Okay? Can't guarantee that, but more than likely, if it's listed as an article, it's a paid article. Okay? So, first question is then, who paid for this study? So, we got to look at that. So, the funding, the sources, and disclosure. So, the first thing is for the majority of the funding was by the Canadian Institute of Health and Research. Right? Now, uh, like with all other government agencies, whether it's Canadian or U.S. NIH and such, there are a lot of politics involved in who they send money to and why they send the money. So while I can't say there's 100% bias here against stuff, we know that there's pretty much a bias towards helping pharmaceuticals. Okay, with any of these government-based institutions because they get most of their funding and they get most of their work through these institutions, and that's the bottom line. So they're buttering their own bread, so to speak, right? So you always wonder about that. Secondly, it should be the some. Okay, that's okay. Uh, there's a conflict of interest statement, which always are interesting when they're included in these researches. So Hang, right? So the three primary researchers, Hang, Anhe, and Scherzer, hold a patent related to the products that they're talking about here. And then this Andrei Tetrov received research funding from Johnson and Johnson, Medtronic, BioTwin, and they acted as a consultant for Bausch Health, Eli Lilly, Novo Nordisk, and Bio. Boy, you kind of wonder about those conflicts of interest there, right? All right. So real quick, primary public funding was from Canadian Institute of Health and Research. It's a political organization, obviously, right? Because it's political. So yeah, there's going to be biases towards not towards doing what's good for your health in terms of promoting a healthy diet, but towards pharmaceuticals. And then you have commercial interests held by the authors and their industry affiliations. So yeah, there are some big problems with this particular one, and so you always have to look for those things. When you see somebody say, "Oh, this study proves you need something," always follow the money, right? Okay, and final, yes, while CIHR funded the study, but the authors also hold a patent connected to the intervention, and some co-authors have financial ties to industry players. So uh, these disclosures do reinforce an earlier critique about engineered interventions for manufacturer dysfunction, which is why I'm saying that, hey, they built a disease. Okay, so let's get into this. So, researchers created a problems that they then sold solutions to, right? The 2025 Cell Metabolism study by Fang et al. Proposes a polymer trap to capture D-lactate in the gut, promising to improve blood glucose and fatty liver disease. The intervention shows promise in obese mice, but examine the methodology closely and a troubling pattern emerges. First, the researchers fed mice an extreme diet of 60% fat plus high sugar, creating artificial metabolic dysfunction. Then they developed a pharmaceutical solution to manage one symptom of that dysfunction. This represents a fundamental flaw, right, in how the study was put together, right? Then let's look at the quantitative reality, right? So D-lactate operates at micromolar concentrations in circulation, right? That's relatively small. Insulin and glucose function at millimolar levels, even smaller levels, okay? So the scale difference matters enormously. Clinical studies demonstrate that hepatic DNL contributes 11%, 19%, and 38% to liver fat in lean, obese, and obese NAFLD groups, respectively. This process correlates directly with 24-hour plasma glucose and insulin concentrations. Hyperinsulinic obese subjects show a 3.7 to 5.3 fold higher fractional DNL than their normal insulinic counterparts. The driver isn't a microbial metabolite. It's carbohydrate overload and the resulting insulin response. Okay? So, if insulin and glucose, which are recorded in millimolars, right? And versus D-lactate, which is the influence range is in micromolars. I mean, well, that's a significant difference, right? You know, thousands versus hundreds, right? It's like that's a significant difference in which one's going to affect your health the most. Okay, so if you have a question about that, let me know. Okay, artificial creations create artificial solutions. So standard diet-induced obesity models use processed chow that no species would encounter naturally. This creates extreme metabolic pathology that amplifies the apparent importance of secondary factors like D-lactate. Under more realistic dietary conditions, D-lactate levels remain minimal. The polymer trap appears effective because it addresses a symptom of an artificially created problem. Remove the extreme dietary stress and the need for the intervention disappears. This methodological bias runs deeper than individual studies. This is how a lot of studies are put together. Then we have the circular research ecosystem. So modern metabolic research follows a predictable pattern. Induce dysfunction with processed diets or extreme models. Document the resulting pathology. Develop pharmaceutical interventions to manage the symptoms. The cycle reinforces itself through funding mechanisms and regulatory frameworks that favor patentable solutions over dietary prevention. Ultra-processed foods increase cardiovascular death risk by 50% and anxiety by 48% in large meta-analysis. Yet research continues to normalize processed diets as baseline conditions. The result is a pharmaceutical research ecosystem that manufactures problems to justify engineered solutions. Okay? What ecological validity would reveal? If studies using ancestral or minimally processed diets show fundamentally different metabolic profiles, microbiome ecology shifts toward short-chain fatty acid production rather than lactate fermentation. Insulin sensitivity improves. Hepatic fat accumulation decreases through reduced de novo lipogenesis. D-lactate becomes a minor footnote rather than a therapeutic target. The mechanistic focus shifts to the real drivers of metabolic dysfunction, insulin and glucose. Independently regulate hepatic LDL by activating SREBP1C and CHREBP, driving the conversion of carbohydrates into liver fat. And what you get is so I mean that's normally done. So this represents the primary pathway, not the microbial metabolites. I'm sorry. So remember, this should be handled normally by just improving your diet, not having scientists say, "Hey, let's create a problem, then let's create a solution, and then create the problem, and then we can sell it," which is kind of what I'm trying to show there with that picture. Okay, the paradigm shift required here. So metabolic research needs fundamental reorientation toward ecological validity and root cause prevention. This means studying humans on minimally processed diets rather than populations consuming standard Western fare, which means you look to optimize, not just fix a symptom. It means using animal models that reflect species appropriate nutrition rather than extreme synthetic chow. Okay? Don't create a problem and then find a solution. Fix the problem. The focus shifts from managing downstream symptoms to preventing upstream dysfunction. Precision nutrition strategies using genomic and metabolic phenotyping offer individualized dietary interventions. Longitudinal cohort designs track prevention rather than acute pharmaceutical effects. Food system changes become scalable interventions rather than relying solely on engineered solutions. Okay? There are practical implications. For individuals seeking metabolic health, the D-Lactate study offers an important lesson about evaluating research. Ask what baseline condition studies use. Research built on processed food consumption may model artificial dysfunction rather than fundamental human physiology. Prioritize whole foods over ultra-processed alternatives. This addresses the root drivers of insulin resistance, hepatic fat accumulation, and gut dysbiosis simultaneously. Minimize refined carbohydrates and added sugars. This reduces both the substrate for hepatic DNL and the fuel for problematic bacterial fermentation. Focus on dietary diversity with minimally processed ingredients. This supports healthy microbiome ecology without requiring pharmaceutical intervention. The most potent metabolic intervention remains diet quality, not symptom targeting engineering. All right? So, beyond symptom management. So, the Fang et al. Study represents sophisticated biochemical research that identifies real mechanistic pathways. D-lactate does influence hepatic metabolism in certain conditions, but the intervention addresses a manufactured problem rather than fundamental metabolic health. True metabolic research would prevent the conditions that elevate D-lactate in the first place. This requires examining how modern food processing and refined carbohydrate consumption create the very dysfunction that pharmaceutical research then attempts to manage. The solution isn't more sophisticated traps for individual metabolites. It's returning to dietary problems, patterns that support natural metabolic function and eliminate the need for such interventions entirely. Okay, this was an overview. I'm going to have a series of Q&A sessions that follow this up to get into very specific ideas so that you can really see how we evaluate studies and look at them and say, no, this is a phony study, because this is a perfect example. There really isn't a problem here. They created the problem, which they happen to have a solution for in terms of a pharmaceutical agent that they could sell you. Okay? It's just the nature of the beast here. All right. Thanks for watching. If you have any comments or questions, put that in the appropriate section. Let me know what you want. This is a community here. I'm trying to answer your questions and help you learn how to actually look at stuff. So let me know what you're thinking, what you're asking for, and we'll try to find those solutions for you. And as always, please, if you haven't done so, like the video, subscribe to the channel, and share it with a friend. It helps the channel a great deal, so thank you. And it also helps a lot of other people. So have a great day.